Okay, let's start the projectile motion. In the previous class, we have discussed the general motion. That is motion maybe in 2 dimension or maybe in 3 dimension. Now we are specific to the projectile motion. Now projectile motion is nothing but motion in 2 dimension, or we can say motion in a plane. Now then we have to decide in which plane. Generally we consider earth surface and the perpendicular to the earth surface. So generally we say x axis I am taking horizontal and y axis I am taking vertical. So this is called vertical xy plane. Remember, x axis is on the earth surface and y is basically the height. So projectile motion is nothing but motion in 2 dimension, and the plane is the vertical xy plane. And later we discuss this trajectory happens to be parabola. That's why sometimes projectile motion is also called parabolic motion. So projectile motion is nothing but motion in 2 dimension, or motion in a plane, or it is a parabolic motion. Correct? Now the question is, what are the different categories of questions in projectile motion? Now for our convenience, we generally divide the projectile motion into 3 different types or 3 different categories. What are the categories? The first category is the point of projection and the point where the projectile is going to strike are on the same horizontal plane. That is called ground to ground. That is point O and A are at the same horizontal level. Okay, that is called ground to ground projectile. That is the first type. Second type is the projectile is projected from a certain height. Maybe somebody is throwing a stone from the top of a building. So that means point of projection is at a certain height. So that is called projectile from a certain height. Now whether it is projecting horizontally up or down, that is a different situation. But point of projection is at a certain fixed height. That is called second type. Third type is the particle is projecting up the inclined plane or it is down the inclined plane. Generally we say projectile on inclined plane. So again remember, for our convenience we divide the projectile motion in 3 different types. Ground to ground, sometimes we call it level ground projectile. Correct? Second is projectile from a certain height. Third is projectile on inclined plane. To start with, first I will discuss projectile from ground to ground or projectile on a level ground surface. Now in most of the cases, let's say x-axis is the horizontal, y-axis is the vertical, so it is a motion in xy plane. Let's say a particle is projected with a certain speed u at an angle theta with x-axis. Okay, so u and theta is given to me. Maybe 10 meters per second, maybe 30 degrees. Now whenever we are discussing projectile, there are certain assumptions. Assumption is that the height that the projectile will go is very small compared to the radius of the earth. In that situation, we assume that the acceleration due to gravity is not going to change, or a small g remains constant all the time. It is an assumption. Second assumption is assuming that wind is not blowing. So whatever velocity I have given, it is known to me. Additionally, it is not going to get velocity from any other external sources. Wind is not blowing. If it will blow, it is an additional question. We'll discuss later. Third assumption is I am again assuming the surface is flat. Flat surface means the curvature of the radius is neglected, as if it is a perfectly horizontal surface. And O and A, that is point of projection and point of strike, are on the same horizontal level. So 3 assumption: a small g is constant, wind is not blowing, surface is flat. In other words, I can say the particle is moving in uniform gravitational field of earth. In other words, the only force acting on the particle is m into g, or it is self weight. Correct? Now initial velocity, initial speed and theta is given to me, so u and theta is known. First of all, try to write initial velocity vector, x component, y component. So u cos theta I cap plus u sin theta j cap. So take the components of this velocity here, u cos theta, u sin theta. So first we have written the initial velocity. Initial velocity is nothing but velocity of projection at time t is equal to 0. Then acceleration. You already know no acceleration, no forces in x direction, only forces is mg, that is vertically downward direction. So acceleration is only minus g j cap. Why the minus? Because I am taking y up, so down has to be negative. So most important, I got the initial velocity, I got the initial acceleration. In fact, acceleration is constant all the time. Now since it is constant, that means we can use the kinematics formula. Integration, differentiation not required here. Now let's say the first physical quantity we are interested in calculating the velocity of the projectile at a time t. At t is equal to 0, velocity is known to me, acceleration is constant, so v is equal to u plus at. This formula can be applied without any problem. So write u in vector form, acceleration in vector form. If you rearrange, so this is the x component of velocity at a time t, and this is the y component of velocity at a time t. Or you can say Vx is nothing but u cos theta. Remember, this component does not depend upon time. What does it mean? In a projectile motion, x component of velocity or horizontal component of velocity remains constant all the time. And of course it is very obvious because there is no force in x direction. Correct? Y component, of course it will change because there is a gravity effect. And it is Vy is nothing but u sin theta minus g into t. So at any time t, I know what is the x component, I know what is the y component, so velocity vector at that particular time we can write. Somebody might be interested, what is the speed at a time t? Now once I know the velocity, speed is nothing but the magnitude of the velocity, it is nothing but root under vx square plus vy square. This is known, speed at that particular time can be calculated. Now another situation is, somebody might be interested in which direction the particle is moving at a particular time t. Direction means the direction of velocity. Remember, whenever an object is moving along a curve, velocity is always along the tangent. So let's say at a time t, this is the velocity vector, and let's say the velocity vector makes an angle phi with horizontal. Now vector is already known to me, x component, y component. Remember, tan phi is y component divided by x component. Y component already calculated, x component already calculated. Now time will be given to me. At that particular time I can calculate what is the value of tan phi, then we can calculate what is the angle phi. So initial velocity vector, acceleration is given, velocity at a time can be calculated, x component, y component, speed and direction motion. All these three quantity can be calculated at a particular time t. The second is, somebody might be interested in calculating its position coordinate or its position vector. So second possibility is, I am interested what is its position coordinate at any time t. Now remember, in case of kinematics, what is the general formula? S is nothing but S naught ut plus half at square. This formula can be utilized provided acceleration is constant. And what is S naught? S naught is the initial position. Initial position happen to be origin. So in our situation, S naught will be 0. So the kinematics formula, this can be written as R naught plus ut plus half a t square. R naught is 0 because point of projection is the origin. U already known to me, so you can write u cos theta I cap, u sin theta j cap plus half minus g j t square. Everything has to be in vector form. Just rearrange. Then this becomes u cos theta into t I cap plus u sin theta t minus half gt square j cap. So this is the position coordinate at any time t. In other words, if somebody says what is the x coordinate at any time t, we can write its x coordinate at a particular time t will be this quantity. If somebody is interested what is its y coordinate at that particular time, then y coordinate at this particular time can be calculated from this. So either somebody interested in x coordinate, somebody interested in y coordinate, then I can separately calculate. Somebody might be interested what is the position vector. So position vector is nothing but xi cap plus yj cap. Let's say the particle is somewhere here. So at a time t, x coordinate, y coordinate already calculated. So I can calculate position coordinate at time t, I can calculate position vector. Remember, position vector is nothing but the straight line connecting initial point and the point where we are interested. So this becomes position vector. Somebody might be interested, calculate the displacement. Displacement is nothing but this quantity, and this can comfortably be calculated x square plus y square. Remember, this is the displacement vector. Again, somebody say, what is the direction of displacement? Let's say this angle is alpha, then direction can also be calculated. Remember, tan alpha should be what is the y coordinate divided by x coordinate. Y coordinate, x coordinate can be calculated from this two equation. So end result is alpha can be also be calculated. So by knowing this initial velocity acceleration, I can calculate x coordinate, y coordinate, position vector, displacement and the direction. Another physical quantity related to this, if somebody say I am interested in calculating average velocity, that is average velocity of the projectile between 0 and t seconds. Remember, what is the meaning of average velocity? Average velocity is nothing but displacement divided by time. Now in case of projectile motion, if I am interested in calculating average velocity between 0 and t seconds, that means I have to calculate displacement between 0 and t seconds, and remember 0 and t second displacement already calculated here. So root under x square by y square divided by t. So this is the value of average velocity. So remember, initial velocity vector you have to write in vector, acceleration which is constant write in vector, then I can calculate velocity at any time t, components of velocity, speed, direction of motion. Then I can calculate position at any time t. Position means x coordinate or y coordinate, or I can write the position vector. It is nothing but xi cap plus yj cap. Or if somebody is interested in displacement of the projectile, it is nothing but mode of position vector, happens to be root under x square plus y square. If somebody say give me the average velocity, so displacement divided by the time. Displacement is calculated, divide by time, we can calculate this. Okay, now remaining we'll discuss in the next class.